Well, hi everyone. Thanks for coming to this presentation. We're going to be talking about the graphics CI system that we have at Intel. So it's something that we've been working on for the past 2 years, something like this, and it really started to get attraction about a year ago, and so we've got pretty far already.
Yep.
So we're going to be talking today about what services we provide.
Can you stay where you are?
Oh yeah. Okay, maybe you can move out. Oh, you stay. Yeah, otherwise I'm not in the video. So yeah, we're going to be providing. What? It's fine.
Slightly more to your right.
To my right here. Okay. Okay.
Thanks a lot.
You're welcome.
So yeah, so we're gonna talk about the Intel Graphics CI, but also the test suite that we run, IGT, and what changes went through it recently. We're not gonna really talk about lessons learned unless we really have time, and so it's more like backup stuff. And dealing with Linux in products is also something interesting, but I don't think we're gonna have time. But at least you know that it's there if you want. So the Linux kernel, it is a massive beast. So we get, basically a release every 63 to 70 days. So that's pretty fast, and it's difficult to do QA on this properly, because the Linux just cuts the final version whenever he is happy with the patches. Doesn't mean that you would have had time to do proper QA on this. There's about 14,000 changes per release. Pretty okay. In average, that comes out at 9 commits per hour. So good luck keeping up with that. That's 1,500 developers. Okay, well, 10% of hobbyists and a lot of companies. What I mean by this is that good luck having a centralized system that would cover everyone's use case. So we are going to just cover our own, and it actually covers quite a lot. It's pretty big, and what is really interesting is that there's a lot of integration trees, hundreds, and then after the release, you get 6 stable trees, which also means that you need to verify that this is still working, because this is what users are using. No one is using the integration trees. So one interesting aspect also about Linux is that it has no architects, which means that you don't have these people deciding what the project is going to look like. It is, I don't know if you've read The Cathedral and the Bazaar, so the essay by Eric Simmons about how Linux is different from anything else. So the Linux development model is everyone just goes there, proposes changes, and then either it gets accepted or it doesn't. So, but there are some rules. And the first one, and the strongest one, is that there should not be any user-visible regressions. So whatever new kernel you would have, it's not allowed for it not to work as well as it used to. So that is a strong requirement from Linux that is very hard to actually enforce when you've got a lot of hardware. Then, of course, the kernel changes need to be open source, fair enough. And the kernel features cannot land unless you've got a user space that goes with it. That is the general rules of Linux. Not all of them are problematic for us. The problem is the first one. So why do we need continuous integration? So when you've got that many people working in parallel on a massive, we can't really do anything about it, sorry. I'll be saying what is there anyway. So when you've got that many developers, like 1,500 working on different parts of the kernel, and a developer at some point is going to be changing the memory subsystem, and it's going to affect in very weird ways other parts of the kernel, for instance, graphics. And so how do you teach people what are the dependencies between the different components of Linux? Well, you can't really, but if you make a test system that shows that there is a regression and let the developer know as early as possible that there is this interaction, then they can rework the patch before it gets inside the Linux kernel. So that's why pre-merge is so important. Because once it has been merged, it's very difficult to get it reverted. So some people are fine with it, and they're going to revert very quickly. But our experience with the the rest of the kernel is that reverting anything is almost impossible. Even sometimes before it even lands into the RC1, we say like, hey, this is not okay, please revert. And they just say like, oh, I'm going to fix it, I'm going to fix it, I'm going to fix it. And then sometimes it even gets released like this. So yeah, the sooner you know, the better. So yeah, one very important aspect for our development team is that we have our own integration tree that pulls in a lot of other integration trees. And we don't want developers to be using like one version, a blessed version of the integration tree, and then let the rest change. We really want to be rebasing all the time and checking that the current integration tree or the merge of every other integration tree is still working for us. So this is still in the idea of testing as quickly as possible, so as you have more time to react. And one problem with that is that it would be very often broken. And so how do we make sure that it's not broken? And how do we make it as stable as possible so developers can concentrate on making their patches work without fearing regression? Well, it's by doing pre-merge testing. So that's the goal of it. And yeah, very important is that it scales better with the number of developers because we put the cost of integration on the actual developer who is making the change. And when you've got 1,500 developers, there's really no other way. Okay, so now, of course, it's all nice and good theory, but then, like, what are the actual challenges that you get out of this? Well, keeping the integration tree is indeed very difficult because whenever you get a back merge from Linux or from an integration tree, you can get thousands of lines of code, even more, coming into the integration tree that have not been tested because other CI systems are not necessarily as thorough as what we do, or at least they don't concentrate on the workloads that we care about. So that's a lot of code landing at once that is untested. So that's usually LC1 is a big problem for us. So usually, I mean, it used to take, I don't know, 2 weeks to stabilize everything. Now we are down to usually 2-3 days. So huge improvement thanks to CI, but still it's problematic. And another problem also is that when you make a bug fix for a particular branch, it may work great on the integration tree, and then you ask it to be merged to stable kernels, and what the patch was supposed to fix, it actually makes it worse. And that's something we've seen. And so if you are about to apply a patch to a tree, you need to test the integration of this patch on the tree you want to apply it to. So that means even for stable branches. Okay. And I'm going to hand over the mic to Arek.
Yep. Yeah, so I'm Arek, and I'm one of the maintainers of the IGT GPU tools, as it happens. So I think it's good that I will be talking about that. I'm also maintaining some of the parts of the infrastructure that we run tests on. So I'm helping with that quite a lot. So IGT GPU tools, what it is, it's a collection of tools and tests that are aiding the development of DRM drivers. Actually, there are mostly tests. We have 40-something thousand tests, 60-something thousand tests right now, 61,000 tests, and we are running them quite often. Not all of them, a sensible subset of 4,000. Let's say, because we are skipping the gem concurrent. So recently we made a couple of changes for the project to aid new development. So we changed the name. Previously it was named Intel GPU Tools, but we dropped the Intel from the name because we support other drivers as well. So it's not only Intel now. We support AMD GPU, have a couple of tests for that. We have a couple of tests in integration with NVIDIA drivers and a couple of tests for VC4. So it's more than Intel. We also moved the mailing list, so people won't be off-putted by sending mails to company-named mailing list. We have separate IGT vendor agnostic list for the IGT now. And also we are starting migration from auto tools to Meson build system because it's much faster and it's nicer and it's this new shiny thing all people like to work on. So yeah, let's take a look at what tests we have in IGT. So 61,000 tests in total. There are 18 tests dedicated for the AMD, 27 tests for VC4, mostly by Eric and Holt. And also we have 1,500 tests for KMS, and those should be mostly vendor agnostic as well, because KMS is cross-vendor API.
Maybe say what it is.
Kernel mode setting, so it's for setting the resolutions and displaying images on the frame buffers. So those should be mostly vendor agnostic, and we have Intel-specific gem tests, which are the most. And as you can see, we have 2,300 of the tests without the gem concurrent, which has a combinatorial explosion of edge cases, and it takes quite a lot of time to execute them all. So we are not executing them on a regular basis, but they aid the development. So that's this kind of tool. So let's talk about why IGTs are more than Intel. Because we are not only DRM driver, we can share huge parts of the code base for the testing and the testing infrastructure as well. Because KMS is not driver specific, as I mentioned before, so all the DRM drivers follow the KMS, and we can test that together. Because API have to be consistent. So if something passes on one driver and not passes on the other, and what behavior should be consistent across all of them. So VC4, Intel, AMD. So that's good to test using one suite. And because why should we duplicate effort? Because Eric started something called VC4 GPU tools. And it's a smaller project, but then he ported most of this stuff, I think, to the IGT. So yeah, for that. And what has to be done? So it started as an Intel project. So there's a lot of Intelism there. And as we'll show you on another slide, not all of the tests are passing on other GPUs because of the Intelisms that sneaked here and there. And cleaning them up should be rather trivial, but we need your help with that. And also, we are not handling multiple GPUs per host yet. So it usually defaults to Intel 1 first.
Yeah, you can guess why.
You can guess why.
There's only
because
one Intel GPU at a time.
Because of the history, yeah. So and one GPU at the time. So handling multiple GPU configuration to test the one you have, if you accidentally have discrete GPU and Intel GPU, that should be done. And it's one of the requested features. So let's see how it looks with. Okay, so it was cut off. But I will read that to you. So we tested Nouveau, VC4, and NVIDIA blob drivers. And as you can see, for Nouveau, we have 125 passes. For VC4, it's 118. And for blob drivers, it's 20. So, but don't blame the drivers. It's not fair comparison, because most of the fails are because of the requirements on Intel hardware that shouldn't be there in the KMS tests. So those are the low-hanging fruits that you can just jump in, run the tests on other GPUs and fix them quite easily. It's about 90% of the fails and skips, I think, for the KMS.
Yeah, for the open source drivers. For the proprietary driver, it is not all the API is implemented, and that's why it's just crashing on it. But it's good information, right?
Yep. So we know that it's the 20 tests passes, so that's not bad.
There's some things that are
standard. So let's also talk about Intel GFX. So now we know that we have a test suite. Yeah, and now about the infrastructure we run it on. So we want to provide an accurate view of the state of all hardware and software configurations we support. So we try to run as often as possible on them. And we believe that results should be transparent. So they should list the hardware configuration. We have a page that says lists all the hardware configuration and the assigned labels. And in the results you receive from the system, you have the name of the configuration and the results, and every deltas, every changes in the test state. We also believe that it should be fast. So basic results should come in around 30 minutes. That's heavily dependent on how much patches are sent to the mailing list. So usually the test run takes around 10 to 15 minutes for the fast feedback. So this is a small set that just is a sanity check whether you haven't broken anything seriously. So it takes 15 minutes, but if there are multiple other series in the queue, it will take longer. But around 30 is a safe bet. So it should be visible. So we don't want to have a system that makes it struggle for the developer to find the results, to explore them. We are sending them to the mailing list. So if you send a patch series to the mailing list, in 30 minutes you can expect first feedback from the CI system saying that, okay, those tests, you're fine to go, or those tests failed, or those tests changed state from pass to skip or something like that, and with all the devices listed and all the bugs associated if we know them. Also, if the series fails to build, that's even faster, because when we fail to build or fail to boot, it's much faster to send that feedback. And the result should be stable. So we are blacklisting all the tests that we don't trust yet, and we try to work on them, on making them more stable and exploring whether there's actually issues in the kernel driver or in the tests. And for the known failures, we issue bugs, and we blacklist them during the runtime. So the tests are still run. They don't make the hardware going into some strange states, but they're consistently failing for some reason. And we have issues for them. We know that they are failing, and the issues for the free desktop or kernel.org bugzillas are listed along the results. And they do not affect you pass or fail final result. Okay, go. So yeah, so let's talk about current state. So we are providing pre-merge testing for DRM tip integration branch that Martin mentioned. So all the patches that we develop for the i915 should be on top of the DRM tip. We also have pre-merge testing for the test suite itself. So whenever you submit new patch for the test suite, it's also getting tested on our infrastructure and referenced with the previous version of the merged one. Okay, post-merge, we are doing much more trees, so we are doing DRM tip as well, just to be sure that nothing was broken. Linux trees, Linux Next, all the DRM fixes branches, and we also have one branch for Dave Early that he can just push to and test whatever he likes using our infrastructure.
He's the DRM maintainer.
Yeah, he's the maintainer of the whole subsystem. We have totally 74 systems in our CI running constantly, and that's about 21 different configurations. That includes like discrete points in the results, because the different configuration of the displays connected or SKUs.
Oh no, that was actual generations, I think.
No,
okay.
We don't have, and low power and high power systems. So it's from Gen 3 to upcoming systems that were not released yet. So we have from Gen 3 up to Cannon Lake, which should be released somewhere in the future.
Yeah, and so Gen 3 is from 2004, so
Yeah.
about 14 years.
14 years is quite a lot of time.
Did we used to have Gen 2 also? Did they break down the machine?
No, we don't have Gen
Okay,
2.
so it's only the developers.
Yeah, developers can access them, but they are not part of CI. Okay, so we have also sharded machines. As you can see in the previous slide, we have quite a lot of tests, and they take quite a lot of time. And if you would run them on a single host, it would take multiple hours. So we came up with a solution of sharded machines. Those are identical machines in 7 or 8 copies, 6 for Gemini Lake, and we just split the workload among them. So you can get the full IGT run, excluding the gem concurrent, in about 40-50 minutes if there's no queue. So that helps us with delivering timely results. And we have Haswells, KB Lakes, Sandy Bridges, Apollo Lakes, and Gemini Lake. So it's a smaller pool of machines, but those are pretty current, and it gets you with pretty... those results are pretty important because we test the whole suite on them. Okay.
So that's the machines from the past 5 years.
Yep. We also have Xenon machines, the scale ones. We have GVTD, Broadwell, and Skylake for the virtualization testing. We have plenty of different monitors and KVMs and dummies connected to those machines. We have HDMI, DVI, DisplayPort, embedded DisplayPort, MST displays, DSI ones, and connected to Thunderbolt and LVDS. So
pretty much everything you can.
Yeah. And we are running the IGT on that. So we have the fast feedback list of around 288 tests. And those are the ones that run in 15 minutes, providing the first feedback. And then we run the full KMS suite and quite a lot of gem tests. That's around 2071 tests, and they take 50 minutes on the sharded machines. And as of throughput, so we started in August 2016 with 22,000 tests executed a day, and we grew quite a lot. So we total around 850,000 tests executed a day for the whole CI system.
Is that Gen 3 is the iron 45?
Yeah, it is.
Yeah. Okay, and we file the bugs for all the issues we find in the CI usually under half a day. So if there's something new, it gets filed during the workday in less than 4 hours. So that's a pretty good result. And this game is called Spot the Holiday Week. So yeah, Christmas. But yeah, we can see that we execute quite a lot of the tests.
So on the side, I don't know if you can read, on
Yep.
the left side, it's millions of tests executed. And so it went up to 5.5 million
Yep.
a bit before Christmas. And on the other side, it's our number of builds made per week. So yeah, up to 400, sorry.
Yep. Okay, and here we have different numbers of builds per week. So the top one is DRM Intel fixes, the orange one. Then we have the cast.
Just see the DRM tip is the biggest one.
Yeah, DRM tip is the biggest one. It's the long blue one in the middle.
Oh no, that is patchwork.
That's patchwork.
Yeah. So
Okay.
patchwork is pre-merge testing.
Okay.
So what this slide is showing is that post-merge testing is basically using about half hour time, and then the rest is
The post-merge testing of all the other branches.
yeah, pre-merge testing of DRM tip and
Yep.
IGT. That's the main thing.
Okay.
Oh.
Here we go.
Well, we've been going pretty fast. That's surprising, actually.
I tried to squeeze it a little bit for you. I know how you love to talk.
Okay. So what we're going to show you now is a demo of what we provide. So this is the landing page of our graphics CI, and because we're engineers, we don't really care about the design. Sure, we do graphics, but ultimately, it's an engineering UI. You just want to get to the point. And I don't want to be writing as much HTML as I'm currently doing, actually. Okay, anyway, so first things first is knowing what our system is running on. So you've got two things. You've got the short hardware list and the full one. So we're going to have a look at what we have here. So whenever we report a bug, we would use the host name as an indicator of what it is, because you don't want to be explaining the entire configuration about every machine you report a failure on. So it's easier to just have a nickname, and then if people are interested, they know where to go. And if they don't know it, we can teach them. Because the people anyway who are going to read that are our developers, and I think we can teach, I don't know, like tens of developers to understand what it is. So you've got the host name, what users would be usually reporting. So you can see the name of the brand name of it, what generation it is for the CPU and GPU. So that's the nice nicknames, like the public ones, not the ones we use most of the time. Then you can see what are the connectors available on the machine, and then you can see what is not connected. So for instance, on the first one, DVI is not connected. But if a developer would be interested in testing DVI because he or she has a reason to believe that it may be more problematic than anything else, then yeah, we can get a request to connect it, so we don't have to have as much communication as one would expect. So for instance, there is this ELK machine here has been very problematic with DisplayPort. On DisplayPort, the machine just dies when executing a certain test. But in HDMI, it's fine. Who would have thought? So that's the sort of things that is very important to know. Oh, and it's not updated. Oh, well done. Okay, cool. Then if you want to have full information about the hardware, then you can go, for instance, yeah, this Braswell here, and you can have all the stuff. So CPU info is, well, you know, proc CPU. So you can check that. Then you can also check what is available in the BIOS, the hardware configuration, if you want to look at the RAM. Okay, you can see what RAM is available. So this one only has one RAM, and it's in, you know, like in memory channel A. You can see the clock, you can see the voltage, you can see really a lot of things from this. Okay, the host name IO mem, so to see where the BIOS is putting every peripheral in the physical address space, and things like this. So that was the first two links. Okay, a lot more to go. Next thing, post-merge. So that's all the trees that we test. IGT, DRM tip, Linux tree, blah, 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 blah. What matters is that on the side you have fast and full. So we're going to take DRM tip and go for the issues, the fast issues. So here you don't see the list of 288 tests that we are running. You only see the issues for the past 5 runs or more, or 6 runs. For the past 6 runs.
5.
Oh, 5. Okay, I knew how to count and not. And you can see what is going on. And here at the top, you've got the list of machines that are being tested. So there's a decent amount, especially for when you don't have a 4K monitor. But you can see that, well, I mean, everything is fine, right? Most things are green. Yeah, sure, but not across the board. On this Sandy Bridge, this test is the problem. And then actually, not every time, because apparently once in these 5 times. And so if you want to know what is going on, you can click on the test, and you can see across all the machines on the vertical axis, and way more runs. So you can see that on this Sandy Bridge, this test has been problematic, but quite sporadically. So that's a nice view. And then you can click on it and see what is going on. So you can see the list of commits that was added between the previous version and this new version. So if there is a regression, you could find more easily already who to blame. No, don't assign blame. No, I'm sorry. Who to contact? Okay, very good. Then you can see the log of the execution of IGT. So, well, in this particular case, it's just the timeout. The watchdog just killed the machine. Like, wah. Nothing moved for 10 minutes, so it just, yeah, freaked out. So this one is probably, since this test is about reading all entries in debugfs, there is one that allows you to read the CSC that of the output, and if there's no output, the CSC is, you're just going to wait for it. So it likely is the problem that in the kernel, it thinks that it has a display active, but actually it doesn't, and so it just waits for it. Oopsie. But you can see also the boot log, so whatever happened at boot time. So apparently this one was taken from the CRL console. Up. So nothing interesting. So that's what happened before we started running the tests. And then dmask here is what started after running the tests. So you can see that, oh, watch, our watchdog is opening the watchdog, and what timeout it set, like 100 seconds. Then you can start seeing that a certain test is executed here. Core it started executing, then starting this particular subtest, and then this subtest is done, blah, blah, blah. Okay. So that was the fast one. Obviously, if you look for the full one, you're going to get a lot more issues. Yes. Okay, so that's the list of issues. Only the issues, so think about otherwise loading the entire page. It takes freaking forever. So you don't have as many platforms as we said. We only have the Sandy Bridge, Haswell, Apollo Lake, KB Lake, and Gemini Lake. So all of these are the recent platforms. And you can see that there is like sporadic noise, and this is what is the enemy number 1 in CI. You really want to have stable results, because otherwise developers are not going to trust when you tell them, hey, actually your patch is problematic. So this is what we need to address. This I don't know if I can move more left. But all this area here, that's bad. That's really, really bad. If it's consistently failing, super simple, right? It went from fail to fail. Who cares? But when randomly a test goes from, pass to DMESC 1, or I don't know what it is. Oh, it's a bug. Okay, so DMESC 1 probably. That is problematic because the patch has nothing to do with it. But how can a stupid CI system know that? So you'll have to have another layer of bug filtering, and we're going to talk about it later. So that is the first layer, just presentation of raw results. Okay, so we're not going to click on the all things because you know what it means. It's going to take forever. So we're not also going to care about the other trees. It's exactly the same logic. So now for pre-merge testing. So we do pre-merge on the graphics CI main list, on the, well, basically for DRM tip, for IGT, and well, that's it. Let's not care about the tribot. So I don't know if you're familiar with patchwork. So patchwork is something that got developed by someone actually.
OZ Labs. OZ Labs, so it's a part of IBM, and it was developed quite long time ago, and then it was not developed for a long time, and our peer, Damien Lespiau,
Yes, exactly. So
he picked it up for development, and then the original patchwork started to catching up, modernizing the user interface and having all the nice features. So kind of we are now in the fork situation when we have the free desktop flavor of patchwork with all the modern features, and there's also the original one. We are using the free desktop one, obviously. So yeah.
And Arek is also the maintainer of this this fork. So one nice thing about it is that it has support for patch series. So rather than having a lot of patches and just selecting individual patches,
The original one also have now
Ish, but
rudimentary feature. For,
yeah. Well, I mean, it's
like
terrible support anyway.
that.
No, UI wise, it's really not how I would do it, at least.
Yep.
So what you can see here are just a series. So one line is one patch series. If a patch series contains 100 patches, then you don't see them in this view. And since we test only patch series, we don't test individual patches. That would take too long. Then you get test results on a patch series. And here you can have a look at, for instance, this test, this patch that was sent by Chris Wilson. You can see when, and you can see that there were 2 revisions of it. And then, oh yeah, this one is bad because of course,
recent.
yeah, apparently he's working on a Saturday. Who? Yes, Chris Wilson. So, yeah, this one is more interesting. So you get a lot of different results. The first one is FICI BAT, so that's the basic acceptance test. That was the fast feedback, fast feedback. So you can see here that there are 2 problems. There were 1 pass to a fail and a pass to an incomplete. But these were not due, potentially not due to this patch series, because we have a bug associating with this particular entry on this particular machine. We're going to go again into that a bit later. So basically no changes, so no worries. You get here a link so as you know what to do, like where to go for if you're interested in this failure, so you can check if it is actually, false positive of the system that suppresses noise, or if it's actually, exactly what you would expect. Then you can see the list of machines, how many tests got executed, how many passes, blah, 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 how long it took, and the list of commits that was before and after the, the list of commits between the previous tested version and new tested version. And if you're interested, you can have a look at the full results. That's the complete, like the A/B comparison. So that's on the first column, it's the previous one, and on the right column, it is the new one. So here the CIDRM 3270 was the baseline, and then we applied the patches, and this build was named Patchwork 7875. And so yeah, it's A/B testing. Okay.
So let me interrupt you for a second. So with the patchwork, the idea is that, and can you go to patchwork? Yeah, so the idea is that it's it's as unobtrusive as possible. So it picks up the patches from the mailing list. It has email address associated with it, and it subscribes to the mailing list and parses them for you and arranges them for free. And when the CI system sends the results here, so what you see by expanding this section is also sent out as a reply to the mailing list. So we don't expect developers to know about the tool, to go there to discover that or have the knowledge from somewhere. They actually are replied with the results on the mailing list and the link to the patchwork as well, and the expanded results too. So it's as unobtrusive as possible.
Thanks. Okay. So yeah, we're not going to talk too much about the rest, but there's check patch run, so you can see if it was fine or not. And sparse also check, that's something that we started working on. So as every patch in this case is being tested. But okay, so that was patchwork. We can also verify that the CI system is indeed sending results on the mailing list. And so let's pick up one. Well, here, for instance, you've got this particular patch, and then you get a first result here. So this patch got sent at 8:29, and let's see how fast it was. Well, exactly 30 minutes later. Yep. No, not so bad. Oh, a bit more actually. Oopsie. But generally, that was it. So you get the results immediately in the main list. That makes it much nicer. Not everything is there, but the most important things are there. Okay. Then what else? No, it was here. You may also be wondering where your patch is in the queue. So if it's still waiting on, yeah, you want to know when your patch is going to be tested. And if you get 20 patch series sent at the same time, of course the system is not going to be able to test it in 30 minutes. So we've got a queue system that allows you to check it out. Unfortunately, we made an update to our CI system, and now this is broken, but we'll fix it on Monday. But it's good, because now you can see that...
yeah, because otherwise it was quite like you would be empty on
Yeah, exactly.
Saturday.
It would be empty. So what you don't see on the right is time posted, so you can see how long ago the patch series got posted. And indeed, the last one that we saw was posted 18 minutes ago. Well, the one that didn't get all the results yet. So, okay, and we have it for all the...
Pre-merge.
Yeah, pre-merge. Stop it. I accidentally pressed the SD card. Okay, so that was pre-merge. So actually we're going down. Then, so we've seen how to get the results. Very good. Now, where do the issue get reported? Because if you have a CI system, it's wonderful, but if no one is tending to it and reporting bugs and making sure that the bugs get addressed, it's not going to go anywhere. So we use two of them. There's Free Desktop Bugzilla, which is all the bugs that we make for IGT and i915. And the second one is kernel.org for everything else that is not DRM or X or whatever. So then we can have a look at the system that we use to suppress the test, what we called blacklisting before, but it's more like suppression. So that's the old tool, and later I'm going to show you the new tool that I've been working on. That is a bit shinier. So here what you can see is the list of active issues that we have. So for instance, this FDO blah, blah, blah. You can see what is the status of the bug when it was last updated. The summary of the bug, then what test it affects, so it's actually only this test on this particular machine. And you can see the failure rate, which is quite useful if you want to make a bug report. And you can see the history of when it was seen last and all this. So, well, okay, it was seen only once. That makes it not that interesting, but this one would be a bit more interesting. So it has, this test is problematic on 3 machines, and we can see the history of them all. So, yeah, so you can see that it was problematic 5 runs ago, 6 runs ago, 7 runs ago. Well, basically all of them. And it's potentially fixed already because it was very stable and now it is not anymore. So we probably could close it. So that's the old tool, and it has some statistics and metrics. You can see For instance, the number of issues over time. So it just grew because we added a lot of machines, and we kept on adding machines, but it's slowly going down again. So that is nice. And well, there's plenty of metrics actually, but one that can be interesting for you is to see the distribution of testing requests throughout time, and you can see what is the origin. So this one here, the blue, well, ish is DRM tip. Then you get the tribots that we were not going to talk about it, and then the Intel GPU tools is the green one. So there's only a couple of them, so it's not very common for them. And then what you can see also here is how long it usually takes. So you've got weeks here at the bottom, and then basically each line or each column is showing a distribution of how long it took to test. So for instance here, it means that most of them got tested in about 2 hours, but then we had a long tail, and the highest one was 18 hours. So sometimes it just happens that there's a lot of things happening, and there's priorities and all this. And then you can see the median here. So, and that's what we would like to keep the result under. So okay. So we'll continue with the demo if we still have a little bit of time. Actually, we should. We have some. Yeah, okay. So I can show you the new tool. So this is the old one that I was saying. It's not exactly the cutest looking one, but I've been working on this new tool here that is a bit nicer. So right now there's no issues filed, but you've got a ton of untracked issues because I imported some runs that our CI system made, and then we're going to have a look into one of them. So let's open the first one. So the first one is on this test, on this particular configuration, hardware configuration and software configuration. That was a fail by IGT standards. You can see when it got started, duration, how it got run. You can see the standard output of the tests, when the error output of the test, and even if there were kernel messages generated during the execution. So okay, and you can see the history of this one. So I imported 3 bugs, 3 runs. You can see here, like 3669, 3670, and 3671. And it got them ordered properly. So what we're going to do now is file a bug for this, because why not, right? We want our CI system to be able to categorize, to know what bug it is, in order to filter in CI the results. So we know if Apache series is introducing a new problem, or if it's something that is already known. This is the tool that is going to be like telling the system, this is known or this is not known. So we're going to teach the system how to know this now. So I'm going to just copy this up. Well, okay, it's copied, whatever. And I'm going to file a new issue. So you get this lovely thing. So we're going to create a new filter. And of course, it doesn't fit the screen because, yeah. So there is this string that was very, typical from this bug. It is, this string, RTC wake failed with 1. And this is what I want to match. I want to match this. And actually, I would like to know on which machines it's problematic. And it's telling me that out of the 858 failures that I have currently to get the system to know, 131 are matching this one. So it's pretty good. So it is available on, tag, it doesn't really matter, but it's a DRM tip. Then on 31 machines, that's a lot. 10 tests, and 1 status. All of them are a fail. So since I'm very lazy, I just, added a button so as it would select everything for me. Of course, this is unreadable because the screen is, super small, but I can show what it is. So here are the tags. So if you've got bugs only on Linux tree or DRM next, DRM, or whatever tree you have, then you can select it there. Then you've got which machines the bug is visible on. Well, here it's really impossible to see. and then the list of tests that we want to cover also, and the list of statuses, so the output, like a fail pass, whatever. So you just put all of these, then you just create this. Come on. What are you doing? Demo effect? Come on! Seriously. Well, I mean, it doesn't matter. Let's pretend that I did it here. Of course, it's not supposed to work. I mean, I use this in production and it works, except now in development environment.
Too many eyes.
Yeah, exactly. But then what you need to do then is match this filter with a bug, because we want to report bugs. It's not just to know or not know. We want developers to know also. So the tool is forcing you to associate filters to bugs, one or more. So I already know that this bug is actually this one. It used to be RTC Wake failed with 256, but then the output changed recently, but whatever. So then you just say, like, here is the bug, and here's the bug tracker. Then you put your email address, so as it's known and people can know who to contact, and then you press save. So I need to put one, and then I just press save. And it's complaining because there's no filters. So, well, oh well. But I can show you how it looks like on the production one. I can show you the address, so that's why it's in a different tab. So on this one, you can see it's a bit like the other one, except it's a bit more stylish. So you can see the failure rate, for instance, of this one. So this bug is a performance counter bug, and we have 3 filters matching this issue, because we consider that it's somewhat like 3 ways of the problem to appear. And you can see what is the failure rate of the issue as a whole. So out of the 20 last runs, 21 last runs, 6 times it was problematic. And then you can see that it was more problematic this failure mode than this one, and then this one. Yeah. Okay.
Let's drop
out. So let's. So what we want to do now is keep on doing this for. By adding more hardware configurations, new platforms, and new display types, and especially ones that allow you to plug in and unplug stuff automatically. So that's Google's Chameleon. We want to add more test suites and more tools to do auto bisection. So we're going to see that now. So CI bug log ng is what I was showing you, and we're trying to. We're looking into open sourcing the tool, so everyone could be using it. And then there's EasyBench. I've talked about this project before. It's an auto bisector for changes in performance, rendering, and unit tests. This way, you could improve automatically the bug reports by having auto bisect on it. It would tell you, hey, this actually was introduced by this commit. And if you want to help us, you can help us on the infrastructure, of course, because we're trying to open source it. On IGT, because you can write your own KMS tests or tests for your actual driver. And if you've got self-tests also that are somewhat impacting graphics, like suspend and things like this, then we could even run it in our farm and file bugs, because it affects us, so we'll have to do it. Of course, we're not going to do your QA, because, but if it can be, a synergy, so that would be good. And here are the contacts, if you're interested. I don't know, like, how much do we have?
So we have time for maybe 1 or 2 questions.
Okay. So, yeah, any question?
Please repeat the question.
Yeah, so the question is, how do we select the hardware we run on? And especially, you were talking about VC4, I guess. Oh, that we don't really deal with. So, well, that's a good question. Why not? I don't know. No, we did not investigate. Any other question? Okay.
how do we implement sandboxing for the builds? We do not.
Well, we do.
Yeah, there's separate network, there's separate machines, and if something fails, we just roll them over. So
Yeah, the machines are not running, inside the Intel network. It's really something that is separate, and
the whole infrastructure is completely separated from the internet or the corporate internet. Then we just roll over it and have a new thing.
yeah, okay.
So it's not a question.